Welcome back to the math revision. Our second task is to solve exponential equations. The problem says 2 raised to the power of x equals 10. So here, x is an exponent. To solve equations like this, what we do is to take logarithms of both sides of the equation. This is because the inverse of an exponential is logarithm. You can use any logarithm you like. I'm going to take natural logarithms of both sides. This way you can bring the x outside. So we can rewrite it as x times the natural logarithm of 2 equals the natural logarithm of 10. So x equals ln 10 over ln 2. Using your calculator, you can get the value of x, which is approximately 3.32. Equation with the natural e. E to the x plus 5 equals 60. First, I'm going to subtract both sides of 5 to isolate the exponential term. So we receive e to the x then equals 55. Now I will take the same procedure as I used in the previous problem. I will take the natural logarithm of both sides. The power property allows us to have the power of x to be coefficient, and then we get x times ln e equals the natural logarithm of 55, like this. Because the natural logarithm of e is 1. So we can solve for x, which equals to ln 55. Using a calculator, we get the approximate value of x, which is 4. Let's look at an exponential problem about investment. If an investment will double in value in 5 years, what is the rate of return per year? Let's set the equation first. For every $1 times 1 plus the rate of return raised to the power of 5 years, we can double our investment to $2. In the two previous examples, x is the power, and we used logarithm. Now we notice x is in the base. So instead, we will take power. So what power should we raise to both sides? Because we want to solve for x, which is x to the power of 1. We therefore use the power of 0.2. This is because 5 times 0.2 equals 1. So when we take the power of 0.2 on both sides, the left-hand side becomes this. Because of the power property, so the powers raised inside and outside of the brackets can be multiplied. So we have 5 times 0.2 now raised to the power of 1. So on the left-hand side, we can receive 1 plus x equals 2 raised to the power of 0.2. Using your calculator, you can get the value of that. So now the last step is to subtract 1 on both sides of the equation. So x equals this much. Because we are calculating the rate of return, so here I would use percentage sign. So we can get the rate of return is 14.87%. Again, there are self-practice problems for you to attempt at home. And this is the end of our second topic.